Hello everyone, welcome back. Today we are going to be looking at a set of differential equation problems. I have never ever seen these problems and I'm going to be trying to solving them in front of you, and let's see how many I can solve and how well I do in it. I have no idea how these questions look like. These are the first order differential equations. We have a lot of problems here, but they would just go out of scope for us. Okay, so the first question says that y dash is x minus y cos x upon sin x. Well, this honestly looks like a first order differential equation which is of the type, right, because there is y as well, so y dash plus cot x times y is equal to x by sin x. So I think this should be enough to solve the first question, right? Yeah, obviously you need to calculate e power cot x integral as well. This should be ln mod sin x, right? So sin x times y is x dx. Okay, so I just solved it, right? So y times sin x is equal to x square by 2 plus c. So this should be the answer to the first question. Okay, the next one says 3x square. Okay, so this one is just variable separable, right? I'm sorry if these questions are easy. I'll try to get better questions next time. So yeah, you can just variable separate them. This can be solved by partial fractions as well, right? Okay, how about this one? Well, again we have y dash plus 2x by y is equal to 3. Okay, this time it looks like it looks like linear differential equation, but I'm not sure how we have to solve it. 3 minus 2x by y, so 3y minus 2x upon y is equal to dy by dx. Oh, all right, so this is homogeneous, right? Because you can see it is the degree of this equation is 0, because yeah, x by y 0 degree term, so you can just put y is equal to xt, so t plus x dt by dx plus 2 by t is equal to 3. So yeah, you just need to manipulate and put all the terms of t with this 3 minus 2 by t minus t. You can do this, and then you can just separate the variables and integrate, right? Okay, how about this one? Y dash plus y by x is equal to 2x 3 by 2 y 1 by 2. Okay, so looking at this one, I'm not too sure. Okay, what can we do about this? We can do this, but I don't think that's gonna help. Nor is it a homogeneous equation. Okay, let's look at this one later, right? So this is, I'm teaching you how to solve the questions, right? Don't always just keep solving. This is clearly homogeneous, so this can be easily solved. X y y dash minus y square is equal to x plus y square e power minus y by x. So xy dy by dx minus y square is x plus y square e power minus y by x. So clearly looking at this e power minus y by x, you need to find the differential of this, which should be x dy minus y dx upon x square, right? So you need this x dy minus y dx. So why don't you just divide by y, right? So this is x dy, so I can also multiply by dx, right? And then x square. So d of y by x e power y by x is equal to x plus y square by x square y dx. Okay, I think we need to manipulate it more, right? Yeah, xy dy by dx minus y square is equal to x plus y square. Okay, what about this one? Dy by dx is equal to cos x plus y. Well, for this I think we should put y plus x is equal to t, because this would yield this, and dt by dx minus 1 would be cos t, and then I can just integrate dt by 1 plus cos t is equal to x plus c, right? Okay, so this one is also solved. Dy by dx, okay, this one is easy. You can just form this into homogeneous by replacing x with x minus h and y with y minus k, where h comma k is the point of intersection of x minus y is equal to 0 and x minus y plus 1 is equal to 0, right? Very basic. Okay, for this dy by dx is cos 2x minus y cot x. Clearly, again, just a normal, we literally just did this one, y times sin x. It's a normal linear differential equation, so sin x cos 2x, and then we can integrate, right? Shouldn't be a big deal integrating this. Okay, dy by dx plus k times y is equal to y power n times sin x. So this is clearly a Bernoulli's equation. So for this I need to divide by y power n plus k times y power 1 minus n is equal to sin x. And clearly, I mean, it's the standard Bernoulli equation, so you can just solve it. I mean, I don't need to explain what a Bernoulli equation is. I just told you what a Bernoulli equation is, or I can just show you right here. So like, this is also Bernoulli equation. You just need to divide by y power 2 by 3, right? Okay, how about this? 2x times dy by dx minus y is equal to x square. So yeah, so I can just divide by this 2x term, right? 1 by 2x, no, x by 2, my bad. Yeah, so again, this is also a linear differential equation. Okay, cool. Okay, how about this? X times x minus 1 times dy by dx plus y is equal to x times x minus 1 square. So for this, do I need to make this as this dy by dx? No, x minus 1 minus dy by dx is equal to y upon x times x minus 1 equal to x minus 1 minus dy by dx. Oh, alright, so this is also a linear differential equation. Right, so they are just making very absurd linear differential equations, but yeah, you can clearly see that px is 1 by x times x minus 1 and qx is x minus 1, right? So yeah, very complex way of writing linear differential equations. Obviously, differential equations is all about that, writing them in difficult ways to comprehend. Okay, y dash plus y by x is equal to 2x power 3 by 2 times y power 1 by 2. So dy by dx plus y by x is 2x times root xy. I'm gonna keep it like that. Okay, so okay, what's the differential of this? This should be, so root y by root x, differential of root y would be 2 root y times dy minus root y by 2 root x dx by x. So this should be 2x dy minus 2y dx upon 2 root xy times x. Yeah, so I think we figured it out. It looks something like that only. Or maybe, oh wait a second, oh I figured it out. It's actually Bernoulli's equation once again, making a comeback, because this is basically x power 3 by 2 and then you have y power n, right, where n is equal to 1 by 2, and then you just divide by 1 by 2 and you would get the solution to this by Bernoulli's method, right? Okay, so we have only one left. Maybe this one is also Bernoulli one, maybe, could be. So x plus y squared times e power minus 1 y by x. Also please do subscribe, because I mean, just look at the time on my tab, it's 3:41. Like, somebody's making videos for you at 4 a.m. in the morning. I mean, not blaming my sleep schedule, but alright, do subscribe though. Okay, so xy dy by dx minus y square is equal to x plus y whole squared times e power minus y by x. So for this, obviously the hint is to find d of y by x, which is x dy minus y dx upon x squared. Okay, now where can I find this? So what I thought was that I can do oh yeah, I can actually divide this whole by x as well. Yeah, I could, I was solving it absolutely correctly. So what we can do here is that I can do this x dy minus y dx. Okay, let's just do one step at a time. Y squared dx is equal to x plus y squared e power minus y by x dx, right? Now I divided by y, right? Okay, now what I did was that I divided by x square as well, right? Now when you divide by x square, you can take this x square inside this and you would be left with 1 plus y by x whole squared, right? Okay, that's also cool. Okay, but I'm left with this y by x term. Oh yeah, so I can just do y by x and then x. So this would be dx by x and all the y by x terms would go there. So y by x divided by 1 plus y by x squared times e power y by x d of y by x is equal to dx by x. So basically, if you put y by x is equal to t, you would have t e power t by 1 plus t squared dt is dx by x. So you have to solve a very different integral. If you have problem solving this integral, you may ask me, but yeah, that's what you have to solve, right? So these were a few differential equations which I solved from scratch. I've never ever seen them, and yeah, I didn't solve them, but I showed you till the point where we could uh, separate the variables. Obviously, if you're having any problems with Bernoulli, because I didn't explain Bernoulli because it takes a little bit of time, but Bernoulli is a very standard thing which you should know if you're preparing for advanced differential equations. Obviously, it isn't in the syllabus, I guess, but for your concept basis, I think you can follow these, like all these full differential, separable, reducible to separable by change of variables, which I just did in cos x plus y, right? And homogeneous, reducible to homogeneous, where we did this. Then linear, obviously, and then Bernoulli. So this is one last thing that many people leave, but you shouldn't. So yeah, I think if you do that, that's pretty much enough. Also, yeah, you also have to find the exact value of the functions on these, and otherwise, yeah, you can check out more. Uh, this is from Oxford Physics Lectures, Ordinary Differential Equations. So I think this is probably engineering mathematics, but yeah, if you like it, you can at least solve the first order differential equations, which are in your JEE advanced syllabus, and these are pretty much relevant because it doesn't get harder than this. So yeah, thanks for watching. I'll bring more content on chemistry as well, and maybe physics as well. Thanks a lot.